when we have a matrix, we can do all sorts of operations with matrices. And let's just talk about a few of them here with this one. First of all, we're going to use R1, guess what? That's row 1. R2, row 2, so forth and so on, okay? But one thing we can do with matrices is we can interchange rows without changing the matrix, the values in the matrix, if you will. One thing we can do is interchange rows. Now, keep in mind here what I'm going for is echelon form, row echelon form. And so you can see here, if I switch row 1 and row 2, that's going to be good for row echelon form, isn't it? Because on row echelon form, we want the first one, the upper left entry, to be a 1. So you see why I'm doing the interchange there? To get that 1 up to the upper right, upper left corner. So the way we indicate it, one way, I will do it anyway. Row 2 with the double, row 1, double arrow row 2, meaning I'm interchanging row 1 and row 2. So I'm just swapping those two out. So it'd be 1, 7, 6, 8. So that row comes to the top, and then row 2 gets shifted down. 0, 4, 8, -2. And then the row 3 just stays as is. Okay? So we can interchange rows. All right, now, again, going for row echelon form. In row echelon form, row 2 is set up pretty nicely because it has a 0 here, right? That's what we want in row echelon form. We want that to be a 0 in row 2. But what do we want this to be?
1.
A 1, okay? And so to make that a 1, what I can do is divide by 4. And so the second thing we can do on these matrices is multiply or divide by any number. Positive or negative for that matter. So I can multiply or divide any row by a number. And so in this case, I'm going to divide row 2 by 4. And replace. So that doesn't change the value of this, anything about the value of these values in the matrix either. So row 1 stays the same. But row 2 I'm dividing by 4. Of course, 0 divided by 4 is 0. 4 divided by 4 is 1. 8 divided by 4 is 2. And negative 2 divided by 4 is negative a half or negative 0.5, however you want to write that. Okay, so let me put, so it doesn't get too confusing, just bring this one over here, down here. So I want to do one more thing at least on this one. All right, so now what we can do is think about, again, trying to get this to row echelon form. We got a good start on row 1 and row 2, but row 3 is kind of a bit of a problem, isn't it? For row 3 on row echelon form, what do we need? We need some zeros, don't we? And so to start anyway, to get that accomplished, let's try to get this here to 0. Now the only way we can get something to 0, we can't divide it or multiply it by anything to get it to 0. The only thing you can do is subtract to get that to 0, right? So here's what we've got to do. Since the only thing that matches up with the 2 here now is the 1, let's think about what I could do with row 1 and combine it with row 2. Well, if I multiplied row 1 by 2, negative 2, and then added it to row 3, to replace row 3, that's going to get that to be 0, right? You see what I'm saying? So that's the third thing you can do, is you can multiply, add a multiple, let's say, of any row to another row. And that doesn't change the matrix value of any of the numbers either. Add a multiple of any row to another row. So what I'm going to do here is I'm going to take negative 2 times row 1 and add that to row 3. And that's going to replace row 3. Not changing, not going to change anything about row 1 or row 2. Row 1 and row 2 are going to stay the same. But I'm going to take negative 2 times row 1 and add it to the row 3, each entry there. Okay, so what do I get? Let me just kind of document it here, kind of above my entry. All right, so negative 2 times row 1. For this entry, that would be negative 2. Then I'm going to add it to what row 3 is currently. And that's what's going to be the entry now in row 3. So if I take negative 2 times the row 1 entry, which is 1, and then add it to the previous entry of row 3, that's going to give me the 0. Now, to make this legal, so to speak, you got to do that to all parts. So I got to do the same thing to each one of these, you see. So now I got to take negative 2 times the 7 and then add it to the 4. So that's negative 2. With me? All right, so now negative 2 times 6 plus, actually minus 10 goes here. So that'd be negative 22. And then negative 2 times 8, add 12. Plus 12. That goes here. So that's negative 16 plus 12, that's negative 4. All right? We'll do one more? Okay. All right, so again, thinking about row echelon form, we're going to do several more of these next time, but thinking about row echelon form, what would be the next step, do you think? Row echelon form. So to be row echelon form, I want these to be 1s, and then below the diagonal to be 1s, but below the diagonals, I need those to be 0s. So I need to get rid of this negative 10 also, don't I? All right? So looking at that, how do you think I can get rid of that negative 10?
Take row 2 times 10, maybe?
So row 2 times 10, right? And add that to row 3 next,
Yeah.
here. So 1, 7, 6, 8, 0, 1, 2, negative a half. Those two stay the same. But now I'm going to take 10 times row 2 and add that to row 3. Well, the good news about the zeros here is that's still going to stay 0. Because 0 plus 0, that's going to be 0. Now I have 10 times 1 minus 10. And that goes here, right? 0. That's what we want. But I have to do that across the board. So 10 times 2 minus 22, that's going to be a negative 2. Goes here. Yes? With me? And then 10 times the negative a half plus, oh, minus the 4. That's going to go here. 10 times negative a half, that'll be negative 5 minus 4, negative. So now my matrix basically is that. Okay? And we're almost there to row echelon form, aren't we?
Yeah, because that negative
Let's
two.
go ahead and finish it. All right, we got time. What would be the last step here then? If I wanted to make this row echelon form, I need that to be a 1, don't I? So we divide by negative 2, row 3, divide by negative 2. 1, 7, 6, 8, 0, 1, 2, negative a half, 0, 0. So divide that by negative 2 now, that's positive 1. Divide that by negative 2, and that's positive 9 halves, or 4 1/2. Ta-da. Row echelon form. Well, what's so good about row echelon form?
Yeah, you can
Well,
see.
row echelon form, you're talking about a augmented matrix, you got the thing solved, don't you? Because now we know that's going to be z is 9 halves, and I can take that z is 9 halves and plug it in to this one, which would be a y plus 2z. Yeah, okay. So that's the idea. We're trying to take a system, you know, that was our original system, and put it into the row echelon form. So we'll do a couple more next time, but that's the idea. One other thing while I'm thinking of it, oh, we'll stop there on that one. One other thing that while I'm thinking of it is, there's another form that they may sometimes reference, and that is reduced row echelon form. And the special thing about that is it just has, it takes it, I guess, one step further, a couple steps further. Reduced row echelon forms has the diagonal is 1, are 1s, but everything else, besides the constants over here, everything else are zeros. The ones off of the diagonal are zeros. So not only do you have zeros below the diagonal, you got zeros above. See what I'm saying? That's reduced row echelon form. And as you can tell, if you've got reduced row echelon form, you've got X, Y, and Z specified out. So the way I'm going to do it is, because we're just going to get row echelon form and then back substitute to get the numbers.